Okay, started the recording. Did everyone watch the video lecture? Yeah, so this is the problem that I was talking about in last class on Friday. Everyone watched this video lecture? Okay, perfect. All right, moving on to our agenda for today's class. I have simply two agenda, okay? First one is homework 7 hints. I'll talk a little bit with the homework 7. And the second one is I'm going to do this problem, okay? And there's an announcement as well. Let me put it here. So exam review, exam 2. Exam number 2 review Wednesday. And exam number 2 on Friday. It has two parts, both in class and take home. Let me announce something for final exam or exam 3. That would be part of it would be in class, like just one problem, and rest of these would be take home. Take home would be due on the exam day. On that exam day, whatever that day is, most likely this exam is on Wednesday. I gotta check, but you understand what I'm saying? The in class one, just one problem, it would be considered as like a quiz slash final exam part one. Just one problem, you'll be doing it on the last day of the class. Okay, you understand? All right, moving into our actual topic. So homework hints. Any question with this exam thing? You're writing. Okay. So basically, chapter 14 would be an exam. I mean, I'll be done with mostly chapter 14 today. This is the last problem we'll be doing. There is a homework already uploaded over there. I'm going to give you hints. You have a week, so there shouldn't be any excuse, right? Everyone's feeling kind of confident? So you're good? Moving on. So exam 7. All right, so there are like 4 problems, right? So let's start one by one. Any one of you started solving any of these? Not yet? You might have noticed already, right? Anytime we have an energy problem, we do what? Like the kinetic energy, which is usually referred by T. Let me see, kinetic energy, right? So if you have two states, like initial and final, okay, 1 and 2, referring by that. So you can write like T1 summation of all the forces 1 to 2, right? T2 is the kinetic energy at point 2. And again, T1 and T2 can be written as, if you know the velocities V1 and V2, right? Half of mv1 square, half of mv2 square. Now I'm giving you hints here, so obviously the writing won't be like in a formal fashion. We don't have time to deal with 4 problem in a formal fashion and another problem, 5 problems. So we're gonna just deal with this as a hint. Okay, let's talk about the first problem. Okay, and I'd like to obviously take it out as well, so this won't be taking out that much of space. Okay, so let's start with this first problem. The first problem, on this first problem, they said here this problem involved integration and this 2 kg block. So this block is m 2 kg subject to force with a F has a 301 plus S. Okay, F has a relationship with position S. Okay, and this kind of complex, and this is in Newton, the unit obviously. Where S is in meter, okay, S is in meter, is in distance, and initially when S value is 4 meter, means assume this block here, say like start from, I would say the way they draw this block is a little tricky to understand. Let me try to redraw something so you'll be understanding. So you have this initial position when the block is here, right? So they said S value is initially at 4 meter, okay? And assuming this s is going in left side, so this s direction is in left side, positive. All right, and s value is here 12 meter. That's what they said, 12 meter. So basically they travel like this block is traveling 8 meter. So it's moving to the left with this speed. So they gave you the velocity at this position. If you're going to say this is v1 with 8 meter per second, right? Determine the speed. So they said find this v2, and then you can obviously name them as s1 and s2 as well, right? So find this v2, okay? And then let me see what else is given. Okay, so the kinetic coefficient means the friction coefficient of the block in the ground, mu s value is given as 0.25. So this mu s, because of the friction force that acts this direction, right? If the block is moving in the opposite direction, the friction force is the opposite to the block force, which is mu s is 0.25 for the friction force, right? That will be needed. And bottom line, this problem you are after this v2, right? And I would say to solve this problem, you gotta use the exact same equation that I was showing before. Remember the kinetic energy T1, right, Joe? Plus what? What are the forces involved here from state 1 to 2, Joe? You think any of the force? Is there, yeah. Is there a friction force? Yeah, there is. Is there a applied force? The F? There is, right? So two forces for sure. We can write it blindly, right? So the friction force and the applied force has two different directions, right? So let's do it like in a universal way. So 1 to 2, right? Summation means like all the forces multiplied the distance or energy, in other words, right? Involved here. U, that's what I'd like to refer, and T2, right? If we're going to go any further, I'm actually giving the solution. Now, first of all, this T1, you know, this is half of m v1 squared. This T2, half of m v2 squared. Christian, what is this m? Do you know the value of the m? Okay, it's 2 kg, right? Okay, so there are two forces, right? One is the friction force, another one is the friction force, another one is what? Another one is the applied force, right? So to find the due to the applied force, to find the u value, okay, for applied force F, again, you won't be seeing me solving this, okay? Applied force F, and this is the most difficult part of this problem. All right. So in other words, to find this UF, if I'm gonna put it as title, let me write it UF here, right? And then you have this force in an integral ds. Why I'm writing it that way? Because you see the force equation, F has this S, right? And then we're gonna find the work, you know, force multiplied distance. So we're gonna do the integration because this S does varies at every point along the trajectory, right, where the block is moving. Does it make sense? So that integration would be challenging. Now, obviously, once you're gonna solve the integration, you're gonna put the limit upper and lower limit, right? So the block does start from the value of S certain value and it ends at the value of certain different value, right? So what would be the upper and lower limit for this integration? Is it like 4 and 12? Everyone got it? So that's 4 and 12. So that's where the challenge will appear. So you have this upper and lower limit is 4 and 12, right? And then you would like to plug this equation here, right? Which is 300, 1 plus s, right? This is ds, and this is 4 and 12. Now, here's the thing. Anytime you have a constant value, you don't carry it inside the integration. You would like to take it out, right? This 300 must is to come out. And then you have this 4 and 12, and then ds 1 over s. Now, do you guys remember 1 over x? What is the integration? Log n, natural logarithm, right? Log x, natural. So you do have this 1 plus s. Now here's the thing, it can do it directly. I don't know how much you know about the integration. You guys is confident about the integration? You know, it will be very much the same thing. If you're gonna do this integration, it will be ln of 1 plus s. Why? Because you can assume this 1 plus s as some third variable. I don't know, x. Say like x equal to 1 plus s, right? Then you're gonna do like ds, it means the derivative between both sides, right? Then you're gonna do the derivative between both sides, and you'll be getting ds equal to dx. Does it make sense? And then you do the integration, it will become log of x. And now you know what is x. What is x? There it is. You got it? So that's the challenge, and I really like you to solve this. That's all hints I'd like to give. Everyone understand? That part of the integration, please solve it. If I'm gonna go any further on this, actually I'm giving you the solution, because this is the bottleneck, right? This is the chokehold here. If you understand this, that's it. Then you can solve this whole problem. Why I'm saying that? Because the friction, this is the other force, right? That has some work involved. Okay, that one is not that bad. Let me help you with that. So the friction, so the friction would be, okay, so the friction force, first of all, you need to know what is the friction force. Friction force is mu k. Is it mu k? They give you mu s. Well, I don't know why they give mu s. They should be writing, because it's kinetic. So mu s. Let me write what they wrote. It's fine. Multiplied the normal force, where n is the normal force. All right. Now question is, what is the n value again here? Anybody know? Perfect. So it would be mass times gravity. So now, do you know this value of friction force? Definitely you do, right? Because the mass value, what is the mass value, Alicia? It's 2 kilogram. G, you know, right? So this one known, this one known, this one known. So friction force is known, right? Now, we are not after the force, we are after the work by the friction force, right? So let me write it. So work due to friction. So you can write it this way. This friction force, this F, right? This friction force value multiplied this distance. Now here's the thing. This distance would be 12 minus 4, but this would be negative. Why? Because the applied force and the friction force are in opposite direction now, depending on which you are dealing with, right? This is negative. Anyway, so this should be enough. Actually, there's nothing left, like, except you just do the algebraic equations and solve this thing and find the value of the v. And the v value, I believe I give it here as well. It's 15.4, right? So if you have any issue with the v value, that final result is not matching, that means most likely the positive and negative has some issue. It's like you're not properly understanding which direction positive, which direction negative. If you do trial and error, pretty soon you'll be getting this value. Okay, if you're not getting it, and if you're getting it, you understand it, you should be getting it in first trial anyway. Okay. All right. Rest three problems are very easy, not that difficult at all. Okay, let me go with the number 2. Okay. So number 2, you see, you have a spring here. It's for a revolver, and this bullet or this whatever the projectile here, whatever you want to say, it'll gonna move on right direction with some velocity, right? And the question is asking you to find the velocity. All right, so the question gives you a few more parameters, like when the trigger pull, the spring extend to 12.5. So the x value is given for the spring. In other words, initially, if the spring is on a stretch condition like this, right? When it gets stretched, it will become okay. So the distance of this stretch would be this x, which is 12.5 millimeter. Okay, and the ball weight, this ball weight is given as small m is 20 gram. Okay, moves along the barrel. This is the barrel. Determine the speed of the ball or the projectile. They just name it this way. It's the speed of the ball projectile. Okay. So to solve this problem, to find the velocity, you see, you got to do the first law of thermo or the energy balance. I mean, fancy way of saying first law of thermo, energy balance could be also tell here. And the idea is when the spring stretch happens, means the spring force is going to get conveyed to the ball as a kinetic energy, right? When the ball moves, what is the kinetic energy of the ball? Half of mv squared. You know that equation, half of mv squared. What is the spring force energy? Spring force is kx. We know that. In one class, last week I believe, first class, we did one problem. Remember, the spring force is what? Like half of kx squared. Everybody remember that equation? Okay, so the x is given, right, Joe? K is the spring constant given here? The problem? No? Given, right? Yeah, it is given 2 kilonewton per meter. So spring force is given. They call it spring constant. I'm sorry, I said spring force. Spring constant. Spring constant is given, K value, right? So half K x squared. X is given, right? The mass of this projectile or the bullet or ball, whatever you want to say, that is given as well, right? And the velocity they are asking. And I'm saying from the energy balance, whatever energy exerted from the spring is ultimately conveyed to the projectile of the bullet as a kinetic energy. So this spring energy should be equal to the kinetic energy of the projectile, right? There's no other energy involved, right? I wanna calculate how much of the friction happened with the spring force and the barrel, right? For precise calculation, maybe it's needed, but usually I don't know that much about revolver or these things, but usually I'm assuming these are highly lubricated, right? Inside, they might have put enough lubrication so this the friction force could be negligible. This obviously, okay. You can think this way, but precise calculation maybe you still apply that and possibly get like less than 1% or something. I don't know, but I'm assuming that way. So that would be negligible anyway. Okay. So bottom line, here you have the spring force that is exerted to the projectile. So you are saying spring force half kx squared equal, everything is given, half kx, everything given, right? And then equal half of m v squared, half of m known, v is what unknown. We should get into that. That's what I'm saying. This is a super easy problem. I really don't want to write even the equation here. If I'm gonna writing the equation, I'm giving you the solutions anyway, right? So that's all you got to do. Any question, Joe? You can deal with that, right? Easy peasy. All right, moving on to this one. This one is a little tricky because it does have an angle, right? The car is moving on a slope, and that's it. I won't be giving any more hints, right? This is the last one. As you can see, the first one is the most difficult one. Others are much easier. So when the car is moving along the slope, only thing that you gotta care about here is this sine 7 degree, right? So you gotta care about this force, which is mg sine 7 degree. Or in other words, this m is 2000. So 2 megagram means 2000 kg. G is G, 9.81. And sine 7. Okay, so that's your force. Okay, and then you have the slope 7 and the power equal force multiplied velocity. So this is the power. All right, and if you'd like to use the efficiency equation here, so the efficiency would be power of an engine is P divided by efficiency. Okay, I just gave you all three equations. I don't want to talk any further. Please read through the problem and try to solve it based on these equations. Okay, that's it. Question 4, get out. That should be easier compared to the other three problems that we did. Any questions so far? And the problem that I'll be solving is a little extensive, okay? So please, I'm pretty sure I will have enough time, okay? It's just one more problem that I have. Any question you'd like to take notes or anything? I'm putting it in record anyway. This will be available to you in Brightspace as a video, YouTube video with subtitle. No? That's good? All right, moving on. Okay, so this is the problem that we'll be doing. Let me read through the problem. So given a block A has a weight of 60 pounds, this is a English unit problem, by the way, okay? And block B has a weight of 40 pounds. So you see the block A and block B here, okay? The coefficient of kinetic friction between the block and the incline is, there's the value is not given here directly. I gotta give you the value. Mu k. Let me put it mu k for now. All right. So then neglect the mass of the cord and the pulley. What does it mean? No mass, no mass, no mass, no mass, no mass. Okay. Don't neglect the mass of A and B though. A and B are significant. All right. So this is like 60. This is like 40. It's not. I mean, yeah. Just 1 second. Let me get the value for you guys in my notes. For some reason, there's a typo. The mu k value was not given directly. Just 1 second. Let me get the value for you guys. So I have it solved in two different ways. One is when the mu k value is 0. The other one I'm trying to explore. Other one, oh yeah, other one is 0.1. Okay, I have it solved, as I said, in two different ways. Okay, we'll see it shortly. But let's now focus on this problem itself. All right, so it's asking you to find the speed of block A, okay, after the block B moves 2 feet up to the plane, starting from the rest. All right, so speed of block A. So after this block B is moving, the block B is moving how much? 2 feet up. So that much movement happened. And obviously you understand this will be happening this way because block A is heavier, almost 1.5 times, right? So that will gonna push the block B up. Okay, so you got a plan should be determining the kinetic relationship between the blocks. So basically draw the free body diagram and all the forces and apply the principle of work and energy to the system of the block. Okay, so that's how I'm going to solve it. Okay, the first one is the kinematic relationship. When I'm saying the kinematic relationship, obviously I'm trying to get a relationship with acceleration, velocity, and the position because of this pulley rope combination. You guys did the pulley rope combination in exam 1, right? So many math problems you did. So we'll be using that to find the relationship between block A and block B in terms of the velocity and the position, okay? All right, so let's do that. So first of all, you got to know what is the distance for block A if you're going to assume this distance is as a, and I'm going to take it out just to give you the understanding of this distance. And if you're going to assume this distance is as b, right, and assume the total length of the rope is L except this portion, okay? You're ignoring that, but because that is constant, okay? You don't really care about that part. So you have this equation. So first, the solution technique, right? Where you would be using the kinematic relationship. So what could be the kinematic relationship? 2 multiplied SA plus SB should be equal to the length of the rope. I'll understand? Why do I write this? See, for block A, the rope has like a pulley, so it just runs twice, right? See that? So that's the reason. The total length is constant. And then what do we do? If we're gonna use the change of distance, let me write it here. So change of distance, because that's the initial position, right? SA and SB. If you're gonna assume the change of distance as del SA and del SB, right? Okay. So for block A, for block B, then this can be written as 2 multiplied SA plus del SB. What would be the change of distance for the total length? It will be 0, right? Because the length of the rope is constant. There won't be any change in the length of the rope. So that should be 0. And then they said, here's the clue. See, block B moves 2 feet up. Isn't it del SB? Everyone understand this? That's the reason we're doing it. So we can find literally del SA, because this del SB is 2. Okay, and then if it's moving up, okay, you can say this is negative. Okay, in other words, you can say givens del SB is negative 2 feet. You understand? So now you have this del SA should be 1 feet. Now can you find the velocities as well? The relationship of the velocities? Should be, right? So this is your equation. Let me name them is equation number 1. So from equation 1, this 2SA plus SB equal L. Now, can you do the derivative in both sides? Should be. Okay, derivative with respect to time t though. Aline, you remember anytime we have a small t, that means time, right? So we have this 2SA plus SB equal del L divided by del T. Now, what will happen with the rope? The change of length per unit time, is there any value involved? No. The rope will not going to change because it's constant length. So this would be 0. And then you're going to have 2. I know some students may sometimes get confused. So let me even write it in descriptive manner. So you have this thing can be written this way, right? So you have obviously this thing 2 VA plus this is VB, right? Ellen, you got it? So you have, Christian, you got it? So VB equal what? Minus 2 VA. All right, perfect. That's the first part. You see, the question does have 3 steps. The second step would be drawing the free body diagram. Now, when I'm saying drawing the free body diagram, you should be drawing 2 blocks with all the forces involved on that. What are the forces? Like the weight, the friction, whatever, right? The tension force due to the rope that is attached to the pulley. Let's do that. Try at least. the free body diagram of those two blocks. Take your time to finish this as well. And I'm saying for step 2, you are doing what? You are doing draw the free body diagram. Anytime you see me writing FBD, that means free body diagram. You know that, right? Draw the free body diagram for what? For 2 blocks. What are the blocks? The blocks are obviously, if you'd like to use a different color of them. So like this is block A, and so like this is your block B. Two are in 2 different plans, right? All right, and then you have the tension because of 2 ropes, right? And you have the tension because of the 1 rope. Now we're going to talk about it shortly. Then because of this plan is in this way, right? You'll be having a normal force and A. Because the plan where the block B is moving is this way, you'll be having a normal force which is NB, right? Up to this, you guys understand? All right, perfect. So then the whole body, the block A, since it's heavier, it'll gonna move towards what direction? Downward direction. VA is the velocity. And the block B, which is lighter, we're gonna move up. So this is your VV direction, right? The velocity. Okay. And these angles here, right? These angles. So these angles, they gave you this angle value. They said this is 30. Now, since this is a right triangle, if that one is 30, this one should be 60 because the other one is the 90 degree, right? All right. So far, these are like, not that bad. And the other thing is obviously the weight. Where's the weight acting? The weight usually go down vertically, right? And when I'm saying the weight, it should be what? MAG. Or you can say it's WA. It's the same thing, right? And the same thing is true here as well. You can say I have a WB here. And it should be MBT. And this BB is confusing here. So I'm going to put this BB in this way. All right. What is the other thing missing? If you have a normal force, friction. So if the block is going down, the friction should be acting upward, right? If the block is going up, the friction should be acting downward, right? So again, this friction would be mu K. Mu K what? NA. Now we don't know NA yet, but we can find it though. And the other friction would be mu K NB. That's it. Those are the all forces. Okay. Now, if I want to say, can you find the value? Can you find the value of NA and NB? Can you do that? Easiest way could be the convention of x and y direction. I would say go the x and y direction for both of them separately in along the normal force direction. So, in other words, if I'm gonna deal with block A, then the normal force direction would be your y direction, right? So can you do like summation of force in y direction for block A only and able to find the value? And how? You should be able to do that. How you can do that? Take a look here. This tension here, this is the tension. I didn't write it, right? I'm gonna write it shortly. This friction here, those are in x direction. Okay? This NA is in y direction. If you're gonna assume that way, right? This NA is y direction and this W or weight does have 2 components. One in y direction, one in x direction. Do you understand? So then you have a means to figure out the value of the NA or normal force for block A, as long as you know the value of the W and the angle, right? Two things still I need to put it in the block here, in the favorite item. First of all, can anybody tell me what would be the tension force for block A? Okay, let me give you a clue. The tension force for block A here has something to do with the T tension, and tension force of the block B here has something to do with the T as well. Let's take a look here. Okay, so what would be the tension force for block A and block B? Think this way. If it is pulling up by tension T, right, then the similar amount, if you're going to cross it out, right, similar amount needs to come here, and the same amount needs to come here, as if like you're drawing the pulley, you have this T and T here. Everybody remember that way I did explain before, right? Alin, you remember? I did explain this thing before this way. So you have this block B, right? And this tension acting this way, T. Does it make sense? As if like if you are cutting it, that's the way it gets distributed, right, Brad? You understand that? And then you have this block A here, right? And this block A does have a pulley again here. So this T and this T. So this T will gonna get nullified by this T, and there will be a similar T, right, to balance the other T. So how many T is involved in block A? 2T. How many T is involved in block B? 1T. Everybody see that? So you do want to write that 2T here and 1T here, right? So now, Joe, you understand 2T and 1T case that I'm trying to establish here? Okay, so now if you understand so far, this problem should be a piece of cake for you, okay? Because, you see, if you're going to assume some direction here, so let me try to do it. So if you're going to assume some direction, say like this is your X direction, right? We're going to assume some direction here. Say like this is your Y direction, right? You're going to assume this is your Y direction. Say like this is your Y direction, right? Do you understand? Say like this is your X direction. You understand? This is just the convention. And you can understand this 30 degree and 60 degree angles are completely different. So this X in the left block and X in the right block doesn't have the same direction at all, right? If it confuse you, you can literally put it like X prime, X double prime, Y double prime. Does it make sense? That's the user convention. All right. So if that's the case, if you understand so far what I'm just doing, so then it's kind of like so easy, because you see this, you gotta remember the knowledge of geometry. If this angle is 60, what is this angle, Brad? This angle? It should be also 60. Absolutely correct answer. So this should be also 60. So now the other question, if this angle is 30, what would be this angle, Joe? Thank you. Now you have all the angles as well. So can you do, it should be not that bad. So can you do for block A and block B, what you're doing again? Sorry. Okay, so block A and block B. So we'll be doing summation of Fy equal to 0, which is NA minus WA cos 60 degree equal to 0. In other words, NA should be equal WA cos 60 degree. Everyone understand this? Logan, you got it? If you understand this, can you rewrite the same thing for here and write dot 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 dot? Okay, similarly, let me write it. Similarly, NB is equal WB cos of 60 or 30? 30. Thank you. Can you find these values? NA and NB? Should be. So apply the principle of work and energy, right, to the system. So apply In other words, that equation, remember T1 equal T1 plus U1 to 2 equal to T2, that equation I'm referring. So apply the principle of work and energy to the system. And here's the important thing. Would be doing to the system means both the block A and block B together this time, okay? So that's why this problem is becoming very interesting. So you'd be writing, this is the equation that I'll be writing, summation of T1 plus summation of U, which is the work and energy or energy, summation of T2. Now you obviously understand what means 1 and 2. 1 means the initial position of the block, 2 means the final position of the block, right? They gave you the distance travel for block B, right? Remember 2 feet? Del as B. They didn't give you that much info though, right? They gave you some velocities as well, I'm assuming. Forgot. Okay. Yep. They gave you initially both of them. So let me start with the givens. So they said initially both of the blocks are at rest condition, right? So you can say like, okay, VA1, VV1. So you can write it this way. Initially, both blocks are at rest. Disagree? All right. And then the SA and SB, one of them is given. So they said like, okay, SB is minus 2 feet. You remember that, right? The change of SB, the block B. What would be SA then? We did find it, right? Is it 1 feet? I'm trying to write everything, accumulating everything, not necessarily everything is given. Okay, so they also give you the velocity BB equal minus 2BA. Okay. They gave you the weight for block A and block B. What are them? 60 pound and 40 pound. Now, do I need to multiply them with 32.2? No, because this pound is the pound force. Remember that? This pound is the pound force. W is given that way, right? If it's like SI unit, then it could be in kg and you need to find it in Newton by multiplying 9.81. All right, but if you're going to multiply it or divide it, if you're going to divide them to find the mass, you're going to divide them by 32.2 to find it in slug, if you remember that, right? So in other words, MA and MB should be, or mass should be 60 divided by 32.2. That many slugs. And then other one would be what? 40 divided by 32.2 slugs. Okay, and this NA and NV value, you can also write it here, the same thing. So NA should be WA cos 60 and NB should be WB cos 30. Okay, now that you know all these things, you are ready to deal with this problem. So obviously you have half of MBA1, right? Square plus half of MBB1 square plus. Okay, and then you gotta deal with those other forces, right? What are the other forces we are dealing with? Let's deal with for block A first. So block A, you see, you have this normal force, right, which is 60 x direction force I'm talking, right? Now block A, take a look here. This W, right? I'm redrawing it here so you'll understand it better. It does have two components, right? So this component, if that angle is 30, block A is 60, right? That one should be WA cos, I'm sorry, it's just all over the places. Let me redraw it. So that one should be WA cos 60. And this one should be what? WA sine 60. Everyone understand? So now we are doing one important thing. We are doing the summation of forces, summation of energy or work in x direction forces. In x direction, this W sine 60 is acting. Does it make sense, everyone? In y direction, W cos 60 is acting. Now we have seen that W cos 60 and the normal force and A is same, right? Remember that, Brad? But in x direction, the component of W is what? W sine 60. In y direction, it was W cos 60. You understand that? In x direction. Why I'm bothering with the x direction? Take a look in x direction. In x direction, you have all the forces. You have the tension, right? Tension T on the rope. What else? You have the friction, right, in x direction. So you have basically everything in x direction, right? Is there any movement happening in y direction? No. There's no movement happening in y direction, okay? So that's why. So why did we bother to deal with the y direction? To find the normal force. And why did you need the normal force? To find the friction force, which is in x direction. Does it make sense? Can you understand? So these are all linked together. So y direction we only bothered because we need the normal force. Okay? I'm gonna write the final equation and I'll let you solve it by yourself. Can you do that? Sure. All right. Let me write that equation first. So the first one would be 60. I'm dealing with only block A first. So 60 sine 60. And the time that I spent explaining that sine 60 because of this, because I'm using the x direction force, right, Alicia? You understand? So that's the reason. Minus 2t. Now, why I'm writing minus 2t? Take a look on the sketch. Isn't the 2t is in the opposite direction of W sine 60? That's why this minus, right? Now, if you assume the friction is 0, then you can write it 0. If you assume there is a friction, then you should be writing that friction is again the friction is again negative. It's the same direction of 2t, right? So negative of what? Negative of mu k and a cos of 60. And for block A, what is del SA? Or the movement in S? Anybody remember? For block B is 2 feet, right? So block A, it should be what? How much of the movement? 1 feet. Everybody understand? So we're going to multiply this 1 feet here. Now you can do it like, with symbols as well. So you'll understand it later. So this is your del SA, right? What else? This is your friction, right? So this is your friction of mu F, friction F block A, right? This is the tension and this is for weight, right? Everybody understand this? And then just one more second, okay? Brad, we're done. So 40 sine 30. Next class, I'm going to talk about it again, whole thing, okay? Mu k WB cos 30, because we have to deal with so many things today. And minus 2 is the del SB, if you remember, right? Equal half of MBA square plus half of minus 2 BA2 or BB, BB. Now remember, you gotta divide it by 32.2, right? Because the m, so let me write it again, half of MA BA square, that is what this thing, half of MBB BB square, right? So MB, this is this term, okay? And now you'll be solving the velocity. Now you know V and VB are related. Why don't all of you try to solve it by yourself and see if you can do that? Now you can apply the value of mu k as 0.1, solve it. You can apply the mu k 0. Okay. This kind of problem you won't be expecting in class. You'll be expecting in take home. These are extensive and difficult problems. Okay. Anyway, I think I did cover pretty much all the difficult route possible in chapter 14. Okay, there could be still some left, but that should be enough for your exam. Okay, exam is on Friday with these topics. Okay, let me know if you have any question. You too.